Hey guys, so this is the first tutorial video that goes over 1 to 21. So 1 to 21. Alright, I'm going to go over a couple of problems and just kind of set them up so you can kind of see like how they work. And then after that, I'm going to kind of cut you loose and just kind of have you do them on their own. So the first one is number 1. This is basically just asking what is the displacement. Remember, displacement is not how much walking you've done. This is how far you are from the beginning of your travel. So this is the net change in position, right? So the change in position is change in x. So let's take a look at that. Which one of those is that? Change in x. Let's see here. So the change in your distance, the change in your displacement, right, is that. So change in d. So how do I expand upon that? I do the final position minus the initial. So x final minus x initial. And so if you think about that, you plug in the stuff that you have, and you end up with a negative value because look at your initial position. Initial position's here. You don't care about this one in the middle. And then retrace his path to the 169 kilometer marker. So look, I'm going to get 169 minus 233, right? Easy, easy, easy. Okay, now let's look at number 2. How far has he traveled? Now, on that, you actually have to add up the distance between those 3 points, right? You add up the distance between those, because how far is a distance? It's a distance one, right? So let's see. So if I go to... So it's not just 233 plus 132 plus 169 because that's not the distance. Those are the mile markers, right? So I have to actually think, well, what is the distance between 233 and 132? That would be the first distance he traveled. And then I go from 132, and you want to, these are all going to be absolute value. 169 minus 132, so make it positive, right? So 233 minus 132. So this gets you 101. And this right here, from here to here, would get you 169 minus 132, 37. And when you add those together, look what you get. You get 138, right? Okay, so I'm going to go ahead and delete some of that stuff so I don't have crap all over my page, right? Oh, too much. Okay, now let's look at number 4. Now, a lot of these are kind of the same. You are adding, subtracting vectors, right? And you remember if like vectors are going with each other, this is a plus, right? If they're going against each other, these subtract. And then, of course, you have the last one. When they go at right angles with one another, you got to use the Pythagorean theorem, right? That's this guy right here. So let's see. Staggering Theorem. Let's see if I can get this to work. Pythagorean Theorem, a squared plus b squared equals c squared. You can kind of see it at the bottom there, but you have this on your star chart. Okay, and that's because it's the same when you're doing vector addition, vector subtraction. You're saying, well, what would it have been the same as doing if I didn't have to go left, right, left, right, left, right? So you're adding up all the left, right directions. Now, when you're going in if you have a right angle, it would be the same if this is my start and this is my finish as if I were just to have done that. So it's the hypotenuse of a triangle, right? So you should be kind of familiar with some of that stuff. So anyways, let's go ahead and look at number 4. Find the speed of an object that covers 400 kilometers in 5 hours. Okay, so let's look here. So speed, remember if I'm doing guess method, speed, the other word for speed is velocity. 400 kilometers, that's your distance, and 5 hours is a time, right? So what equation is velocity, distance, and time? Velocity equals, let's look at our equations here. Velocity, this is another word for speed, so that's something you need to know. Displacement over time, so d over t, which we already have, right? So show the equation first on your paper so you get full credit. Okay, now I plug in 400 over 5 hours. Okay, so that should get you your answer, okay? Okay, next up we have number 7, so let's look at some graphing. Let's see here. Consider the following graph of motion. How far did the object travel for 2 seconds? So we have to first evaluate, this is very important, to look at the y-axis and the x-axis to make sure we know what we're looking at. So we're looking at a distance, right? This is a distance graph. So from point to point, we're seeing a change in distance, right? So if we have a slope going upwards, it means we're traveling away. This is a positive slope, so that means we have a positive velocity. If we were sloping downward, it means we'd be going towards home. We'd have a negative velocity. It doesn't mean you're slowing down if you have a negative velocity, right? remember that if you have a slope that's becoming more flat, that's going to be slowing down, right? So that's something very important. If you have a slope that's going flat like that, slowing down. If you have a slope that's getting steeper, it's speeding up. But remember, steeper could also go that way, right? So let me draw that with another color just so you can see it. Steeper can also go, I'm getting faster towards home. Red is faster away from home. Black is slowing down away from home. And green will be slowing down towards home, right? So let me go ahead and remove all that junk so we can actually do the problem. How far did this object go between 2 and 4? So we evaluate 2 seconds and 4 seconds. We look at the change we do final minus initial, just like the other problem. So 40 minus 20, show that work, you should get 20, okay? Let's see, and it's constant motion, constant velocity because the slope is constant. Remember, the m of this graph is velocity. Okay, now let's go to question 9. Let's see what we got here. So actually, that's on the next page. So let's go to the next page. So let me go ahead and cut this real quick. All right, so we've got our star chart here. I can actually scroll now. Okay, cool. All right, so let's zoom this guy over here. Question 9. What is the speed from 2 to 4 seconds? So in order to do that, we kind of need to look at the graph again. But let's see, from 2 to 4 seconds. Remember that speed is distance over time, the displacement over time. So I have no idea how ugly that just came out, but oh well. So let's look at the speed from 2 to 4 seconds. So that's displacement over time. So what's 2 to 4 seconds? We had 40 minus 20, so that's 20 over 2. That should give you 10, right? Because that's velocity is displacement over time. And since it was 20 over 2 seconds, that would get you 10 meters per second. Okay, so I'm going to go ahead and erase that. But that's how you do those problems. They're pretty straightforward. You're just looking at the information from the graph. Instead of reading a word problem to find your givens, you're just looking at a graph to find your givens. So I'll continue with that in just a minute, okay? Okay, let's look at question 11. So now we're looking at a different position time graph. So instantaneous velocity at 1. Okay, so remember that if you look at the steepness of these curves, it kind of tells you how the object's moving, right? So right here, it's not moving, right? Here it's moving towards the origin. Here it's passing the origin, right? So now we're in negative displacement. We're losing distance from home, right? But when you're looking at the velocity, you're looking for steepness, right? So right here it's not very steep, it's not moving. Here, steeper, it's moving quicker. Okay? So the instantaneous velocity at 1, since we said we're looking at slope, you're going to look at the slope at second 1, right? So you're looking at the slope of the line that passes through that point, right? So how do you do slope? This is rise over run, right? Rise over run. So what is my rise? I got -2, 0, to 2 to 4. So that's what? 4 minus -2. 4 minus -2. So that's a plus, right? Over, and you can make your slope go from anywhere to anywhere you want. So I'm going to go from, since I went from here to here, I have to use that times 0 to 2 seconds. So that's 2 minus 0 for my final minus initial. So this ends up being 6 over 2. So that should get you 3 meters per second. Okay? And it's positive because look at the slope. The slope is positive there, right? Very, very easy stuff. Okay, now let's see what else we got. Okay, and the last one I'm going to do is 15 because the rest of them are just kind of all reiterations of the same thing. 15 is a little different, right? All right, so this looks like an actual calculation one. Baseball goes from 0 to 30 meters per second. So let's do our givens here, and let me zoom in. All right. 30 meters per second, so that V initial, right? V final in 0.216 seconds, that's time. What is its average acceleration? So acceleration equals. So these are my givens I'm going to put right here. This is my unknown. Okay, and now let's look. What equation do I have in my equation sheet to do that? So acceleration is final velocity minus initial velocity over the change in time, or this equation here. So always write your equation first before you do anything. We've been doing this all year, so if you suck at this now, it's really not my fault anymore. Okay, change in V over change in T. Okay, so my change in V is going to be 38 minus 0 over my change in time, 0.216, and so that comes out to, if you put it in the calculator correctly, you get that. Okay, questions about that? All right, so do you understand how to define displacement, velocity, acceleration using graphs? Do you know how to find velocity displacement using your star chart? This is what you're going to get to use on your midterm, and remember, you can take as many notes on this as possible. Just make sure that you, what am I doing here? Just make sure that you, if you like the equation to be a little bit different, that you make the notes on here. Okay, this is what you're going to be allowed to use. All right, good luck.